Hi, welcome guys. This is the first video for our video notes for you guys here in physical science. Welcome. This is going to actually be a bit shorter of a lecture. It's going to be mainly, or at least a good chunk of this whole video, or at least these next two videos you'll be watching. This one will be the shorter of the two. The other one will be a bit longer, and that'll be the walkthrough on how to make a graph by hand. Okay, so first thing though we've got to cover is we have to cover these notes. So let's just go on through and go through these notes. So first off, student learning objectives. So hopefully after these notes, hopefully by the time we take the test, you can analyze data and organize them into a data table. Okay. Hopefully next you can identify the manipulated and responding variables in a data table. You can identify, define, and also create a bar graph. You can identify, define, and create a line graph, and the same thing for a circle graph. Okay. So data table. So remember, graphing is an important procedure, not just used by scientists, but pretty much by most other people. So like this picture on the side here, HR information. This is like a little snippet of a contract that is more or less just a data table. So you have your position and the salary. So depending upon the position, it'll change your salary. So obviously you want to be the CEO of whatever this company is, so you can make that $1.2 million, right? So it's just an example. It doesn't have to be particularly, in physical science, doesn't have to be chemistry, doesn't have to be biology. Other places, even mathematically, use data tables as well. Okay. What is absolutely clear and what is absolutely necessary for data tables is that the data must be organized and interpretable. Oh my goodness, interpretable for the reader. Has to be. If a reader can't understand what the data is showing or what it's saying, then you've kind of wasted your time making a data table. It has to be organized and interpretable. They have to be able to read it. And then scientists use data tables to organize their data, and there are special rules and methods to follow when making these tables, okay? So data tables, generally speaking, they are used to relate two or more variables from an experiment. And so, again, two or more. So for the most part, we're really just going to be looking at a simple, manipulated variable and responding variable kind of tests. Like those are the only ones we're looking at. There are others, of course, that do look at, a different number of responding variables. So you may, or at least a different number of categories of a responding variable. I guess as an example, it would be like if you wanted to track the number of woodland creatures over, a year. Clearly, you'd have to differentiate the different types of woodland creatures between deer, squirrels, ground squirrels, porcupines, badgers. You'd have to differentiate between them, count them, and then associate them, by the number of months or by the different months that you're seeing them. Okay, so again, just an example. Data tables must contain these 5 specific things. So data tables have to have a descriptive title that references the manipulated and responding variables. It does not have to have the exact wordage of these two variables, but it should include some sort of language that references them at the very least. You need variable headings or headers. You need units of measurement. You need consistent data. So that means that if we're using nothing but numbers, you need to keep the numbers looking the same. So if you have numbers that are, let's say, all for the most part represented with a single decimal point. So as an example, I'll grab my stylus here. So as an example, real quick, I guess it doesn't matter because my toolbar isn't up. As an example, that would be like keeping everything to one decimal point. So it'd be like 98.0, 26.2, 31.8. So it would be making sure your data all looks the same. And then the fifth thing, make sure you have everything is clear, readable, neat, because your presentation has to look good. And especially when we are doing this by hand. Okay. So this does include spelling and grammar. Okay. Can't be misspelling stuff. And especially now that a lot of the material that we're doing is online, there's less and less of an excuse of, not being able to have proper there's very little excuse not to use proper grammar, proper spelling. Okay. And I would say that extends to doing stuff by hand. Okay, so how to make data tables. So this is a very, very broad and generalized list because each data table is going to be different. Every data table, is different and will be different. So these are overarching ideas on how to, generally speaking, put together a data table, a generic one, no matter the test that you're doing. So there's probably going to be steps that I'm missing, and there's not a lot of room here, I guess, or at least there's a lot of room, I should say. There's a lot of room for interpretation and a lot of room for creativity. Okay, but anyway, these are the things, for the most part, you should do to make a data table, and we'll go through and we'll see how we can put one together. Okay, so for the first step, you need to establish what your manipulated variable and your responding variable is. You need to know what these are because they are going to be placed in very specific places in your data table. So you have to identify those first. Once you've identified those, you need to create a box. The box needs to be decent enough size to include all the data that you're going to be plotting in. Okay. You don't want it to only account for one variable and then make a separate data table. It all needs to be under one roof. It needs to be all under one data table. So it has to hold all your data. Excuse me. So the next thing you need to do is at the very top of your data table, you need to have a title. Okay. And like it's mentioned in 2 slides before, the title needs to include language from or at least reference your manipulated and responding variables. Okay. Once you have your title at the top, you then need to split your data table, presumably, because we're working with just 2 variables, manipulated and responding, you need to split it in half, and you need to put headers for each of those variables underneath the title. So this is where it's important about, knowing which variables you're manipulated and which ones you're responding. Your manipulated variable is going to be placed on the left, while your responding variable is going to be on the right. Okay. Or at least throughout the rest of your data table. That's especially true if there's different categories of the responding variable, like I mentioned about the woodland creature thing. Okay. And then you got to write the values associated with the headers in the order in which they align. So a great example of that was from the activity you did yesterday. So yesterday you did that activity, and it was the first question. It was the one that was about the number of deer sighted per month. We started in September and ended in February, but it was presented to you, beginning in September and ending in February. We wouldn't change the order to the actual order of the months because that's not the way we collected the data. And that's not how we should represent the data in the data table, because if you did that, it would tell the reader, oh, well, they, for whatever reason, started counting for 2 months and then they forgot until September and then they started counting them in September. That's kind of weird. And then they just stopped in December. That's not a year. That's missing most of the year. Okay. So we've got to make sure that we are putting in the values and we're putting in the specific wordage, different categories of the or different measurements of the manipulated variable and the specific corresponding values for the responding variable. Okay. And then lastly, color if needed. So this is part of that neat presentation. If you want to put color in it, you can. Just be careful. You don't want to, you don't want a rainbow of a data table, because then that will be too distracting and it would just look bad and it would be just harder to read the data. So you got to be careful. You'll see here in this example that I have, how I color it. I keep it super simple, and I'll mention what I do. Okay, so let's take a look at it. So here is an example data table, and we're going to use this data table in the other video, showing you how to make a graph by hand. We're going to use this guy right here. But anyway, so taking a look at this, you notice real quick, I'll just get the color thing out of the way. You'll notice I use the same, I guess, branch of colors. A thread of colors, I guess, or palette. Maybe palette's the right word. I use the same palette of colors. We'll just use that word. So for instance, if you go to like a color wheel, if you go to Google, here on Google Docs, Google Slides, you press like the bucket button to fill in color, and I'll choose blue. But specifically, I will choose a darker blue for my title, and then for my title here, and then for the headers right here, so city, state, and then average annual precipitation, I'll go to the same color on the menu, but then I'll just go one color up, a color in a lighter shade. I'll choose that, just so it makes it a little bit more appealing. It makes it easier to read, but it also kind of spices it up and directs you towards, directs you to what the data is, and pushes you away from looking at the headers, or at least pushing away from looking at the headers in a way that you don't confuse the headers with the data you collected. And that's pretty much it. It's simple. It's nice. It's tasteful. It's not too much, because if you have different colors, it's going to clash, or like crazy different colors. Like if one was like burgundy and one was like a lime green, like that would hurt your eyes. It would look terrible, and it would just look gross. Don't do that. Okay. Anyway, okay. So look here. We've got, this is already made, but we've got a clear, concise, accurate title that does include our variables. So here it literally, provides both variables. So here we have, average annual precipitation, and then U.S. cities. Okay. Average annual precipitation for selected cities. And notice, see my average? That is the correct abbreviation for average. Not just the fact that it's AVE, but it's AVE dot, period. Okay. So again, we have to make sure grammar and spelling is accurate here. Very little excuses anymore on this. Then annual precipitation for selected U.S. cities. Good. And then here's our header. These are our headings right here. So we have a header for our manipulated variable, because remember, our manipulated variable is going to be here on the left side. Okay. It's clear, it's concise, and it matches with the data. We have city, comma, state. So city, comma, state, city, comma, state. Good. You could get away with just putting city. You don't have to put state over here. You could put other ways of indicating that you're going to, put a state next to it. But again, you could just get away with city. So here again, city, state names and abbreviations are consistent and correct. So notice we don't say Buffalo and then spell out New York and then have Chicago and then just have the abbreviations for Illinois, because that's just not how it works. If we have the abbreviations for one state and the correct abbreviations for one state, we should have all the other states in their correct abbreviations. Okay. So then here's the header for our responding variable. And this is that indication here, right here, our units. So we have average, again, the proper abbreviation, average annual precipitation, and we also have units. Okay, we measured these units in centimeters. So we put those units off to the side. They're in parentheses so that now we, the reader, or us, the tester, understand that this was, either that someone else or that we measured in centimeters. Okay, by basically just sticking a cup outside and seeing how much rain falls in it, more or less. Okay, and then we'll notice all of the values are to 1 decimal point. Okay, you can see that? That's what I was talking about earlier. So all of our decimal points, these are consistent values. This is consistent. This is consistent. This is consistent because of the abbreviations are correct and they're all abbreviations and we spell out the city names. This is consistent and correct. Okay, this is consistent because we are keeping to 1 decimal value. It's perfect. Okay. And then lastly, before we move on to making graphs, here's a pro tip. So when you're making your data table and you forgot, even though this is like step number 1, but you forgot, which one is your manipulated variable, which one is your responding variable. Excuse me. Ask yourself, which variable affects the other? Okay. So it'd be like asking this question right here with this example. Does the city and the state change the average annual precipitation, or does the average annual precipitation change the city or state? Okay. Obviously, the average annual precipitation does not change the city or state. Okay. It doesn't. City and states have, it's not to say that, the precipitation can't change, in particular cities. It's to say that we find that that these places have this. They're not defined exactly by the annual precipitation. So for instance, if the annual precipitation in Buffalo would happen to drop down to 20 consistently, it wouldn't all of a sudden change Buffalo, New York to San Diego, California. Okay, because that's not how it works. We go to this place and we measure this, and dependent upon the place, it'll change this number over here. Okay. So again, you need to ask yourself which variable affects the other. I can talk about this more if you're still confused on this thing. Make sure you shoot me an email, send me something on Remind, talk to me in class, whatever it has to be. Okay, so let's get into making graphs. So just like data tables, graphs are just as important, and they also contain 5 major things. Both of them contain descriptive titles. And what's cool about this is that graphs, for the most part, you can use the same exact title on your graph that you used on your data table. Typically, people do change them a little bit. Typically, they'll be a little shorter in the data table and they'll be longer in the graphs sometimes, but you can keep them the same, okay? But a descriptive title that specifically answers the question, what is this data? And it can be the same one you give to your data table. The next thing is that the manipulated variable is going to be on the x-axis, okay? So the guy that you put on the left-hand side of your data table, yeah, he's going to go onto the x-axis. And remember, that is your horizontal axis, okay? This is your horizontal axis. All right, because again, this manipulated variable it's only altered by us, or at least it's chosen by us. It's not going to be altered by our responding variable, because our responding variable is going to be the one that we want on the y-axis, because that's how we're going to be able to read the data properly. It has to go on the y-axis, okay? So manipulated on the x, responding on the vertical y-axis, okay? So remember, horizontal is the x-axis. The vertical is the y-axis, okay? A legend and a key whenever it's appropriate. Not all graphs need a key. Not all graphs need a legend. But if you have, say, a scatter plot, if you're comparing a different number of trends, you have a different number of lines in a single line graph. If you're comparing 2 different years, if you're like making a bar graph and you're comparing 2 years, like say if you're comparing the GPA of the students here at Sandwich last year with the GPA that's received that was earned this year, then you would have 2 different bars next to one another, and they should be different colors. And you'd have a legend or a key that shows that. That's a little bit down the road. One that we probably won't get into because we're going to keep things pretty simple. because it is more of review and a little bit of expansion, a bit more of defining and creating things on our own. And we'll get into making that, in bio. We'll get into that in chemistry, the more advanced stuff. So what we want to do is just the simple stuff. And then number 5, obviously, you need something to graph your material with. So either you need the paper, the pencils, all that good stuff, or you need a program on the computer. I'll remind you guys again, we're going to be doing pretty much everything by hand. If I do have anything on the computer, it'll be extra credit, which again, I'm still not decided on that just yet. Okay. So we're going to focus in on 3 different types of graphs. And for the most part, these are the 3 most commonly used graphs in science, and it's just pretty much everywhere. So you have your bar graphs, you have your line graphs, and you have your circle graphs. So, and obviously there are other ones. You have scatter plots, there's histograms, there's bell curves, there's all kinds of other graphs, but these are the 3 that we're just going to be focusing on here in this class, okay? And the same thing I'll even say for chemistry. When you guys have me in chemistry or Mr. Hamer in chemistry down the road, we use these 3 graphs. Okay, so defining them. So bar graphs, these are the graphs that compare things between between just different groups. And I'll just keep it at that. So when you're looking at an assortment of data, just remember that it's comparing things between groups. So it would be comparing things not necessarily over time. It can be shown over time. It's just over time. It would be like following something, or at least somewhat following something and comparing them to a different time period consistently as we show the data. I guess is the best way to explain it. And this is best used when the changes and differences are large. Okay, that's the point. We really want to show that difference between, like our values. We want to show the difference between our different measurements. Okay. Line graphs, these compare 2 or more variables over a duration of time. Okay, so these are used to see how something changes over that time period. And these 2 are the most common, obviously, and this is why we focus so much on them, is that because bar graphs and line graphs are so commonly misinterpreted and also misused. Most times when I ask you guys to make a line graph, you make a bar graph. And vice versa. So it's important to know what these kinds of graphs are and how to define them so you can better understand which one to use in a particular scenario. I guess the biggest difference I'll say between them is that, like, bar graphs would be, as an example, you would use a bar graph when you are for instance, like I mentioned before, showing the difference in GPA between 2 different years, right? So you'd have one bar for 2020, you'd have another bar for 2019, maybe even if you had a third one, a bar for 2018, whatever it'd be. A line graph would be, it would be like, it would be tracking the speed of a car over the span of 10 seconds. So you would show the line and the change in the velocity and the speed of the car over the period of 10 seconds, and you could show that either if it continued to increase, it would be like a straight line, whatever, or be straight across, whatever it'd be. Understand, though, they're 2 different things, I guess, is the biggest one. And we'll go through that throughout this week. We're going to really show, why it is we should choose line graphs over bar graphs, that sort of thing. And then circle graphs. Now, this is probably the easiest one to identify and the easiest one to use, roughly speaking. And we use this to visualize data and information concerning a population. And these are used to easily show results of a test or investigation. Okay, so out of a particular population, we would cut up the pie to show like the number of. We would cut it up to show the different percentages of the population that we measure to have this we measure to have this thing, or to be part of this group, or use up this amount of energy, whatever it is, whatever we're testing. So just like the data table, this is also super generic and super broad. Making a graph by hand is a case-by-case basis, especially depending upon the data that you're collecting. So this is an overarching idea of how to put one together. There's going to be steps that are clearly missed because it is graph specific, but for the most part, this does cover most of the steps that you should fulfill when making a graph by hand. So the first thing we need to do is we need to find the lowest number and the highest number in each of our variables from the data table to establish our range for the x-axis and the y-axis. And all you have to know what a range is that a range is basically what's the lowest number I need to include and what's the highest number I need to include. It's just the difference in the, realistically speaking, there's an actual definition. The actual definition is the difference between the lowest number and the highest number in your data. And so you have to understand your range in order to know how many spaces you're going to use on say your graph paper, on your grid lines. Okay. After you do that, you need to make sure that you start your range. You cannot start it with numbers higher than your lowest value, your minimum. And you shouldn't end with numbers or a range smaller than your highest value, okay? Your maximum. You can't do that. And I'll talk about that when we are making a graph by hand. Okay, so you're going to mark your graph appropriately on the x and y axis, leaving an equal amount of space for your ranges. So again, that will be made clearer when we're making the graph. Just understand this is part of that consistency. We want to have our graph look pleasant. We want it to make it look appealing, and we want to make sure any space that we use, any place where we need to space things out, it needs to stay the same for all of our other headers, for our other variables, whatever it may be. We have to make it look nice and neat. Okay, and again, we'll get into that a little bit more clearly when we are making our own graph. We need to label our axes with appropriate variables and include units when we need to include units. Okay. We write our title at the top. We determine the type of graph that we are doing, and then we plot our graph. Okay. And again, so this is super duper broad, super duper general. And this is where it's going to really come down to you to use that information from your previous math classes, from previous science classes, to really use this and put together graphs that we're going to be practicing for the next week and a half. Okay, because it's super important, because these are super broad steps, and it's not terribly obvious, what to do. That's why we really got to stop and think and use our brains and take our time making these. Okay. And then the last thing, connect your dots if you have a scatter plot, color in bars if you have a bar graph, show a trend line if it's a scatter plot, or even if it is a bar graph, show a trend line, show percentages if it's a circle graph. You can label your values on a bar graph or a scatter plot if you want, or on a line graph. Okay, these are things, again, we'll get into when we start making our own graph. Okay, and that's it. That's the notes. So this will be the end of the notes, and I'm going to start making a new video. So make sure you look out and find that second video on how to make a graph by hand. Just so you know, it's going to be a bar graph. And that's, again, all that I have for you guys here. So if you want to know when I'm posting videos, you can subscribe to my channel on YouTube. If not, that's fine. Just make sure you look out on Google Classroom. If there's something that you're not 100% on in this little lecture, make sure you ask me. And that's all I have for you guys. I'll see you in the next video in just a second. Uh-oh. Yeah, great outro, Mr. Sheeline. Yeah, great outro. Let's do it. All right, guys, in the next video. See ya.